Today on Capechi's Corner, we're going to look at properties of proportions. A proportion is an equation stating that two ratios are equal. So in the last lesson we looked at ratios. Now we're going to set them equal to each other. So there's two ways we can write them. We can write them in fraction form. 3:5 is equal to 6:10, or we can say 3/5 is equal to 6/10. Or another way we can write it is in this horizontal method. We say A is to B is equal to C is to D. Now, when we write it like this, it's easy to see what our means and extremes are. Our means are our inside terms, and our extremes are our outside terms. It will be the same thing when we're looking at it in fraction form. So our extremes, again, we would say 3 and 10 are our extremes. They would be on the outside if we were to write those fractions in our horizontal method. And our means would be the other two. Then they would be the 6 and 5. They would be our inside terms. We have something called the means extremes property, and what that says is the product of the extremes, when we multiply them, is equal to the product of the means. We are more comfortable in algebra calling this cross multiplying. So if we look at our proportion, we have 1/2 is equal to x over 16. If I multiply my extremes, my 1/16 would give me 1 times 16 is 16, and then if I multiply my means 2 times x, I get 2x. They're equal to each other. I solve algebraically for x, and I get that x is equal to 8. We have a proportion A over B is equal to C over D, and we have a few properties. We can say that this proportion is equivalent to the following. Number 1 says AD is equal to BC, and that's simply just saying we're cross multiplying there. Our means are equal to our extremes, the products of those. Number 2, we have our numerators. A and C, we've now made them one ratio there, A over C, is equal to the other ratio, which is B over D. That's our denominators. And number 3, we're simply swapping our numerator and our denominator, so we have B over A is equal to D over C. And number 4, I take my first ratio, A over B, and I adjust it slightly. I add the two of them together, I get A plus B, and that's going to be over our denominator B. The same thing will work on the other side. I take them C plus D is over D, and that gives us an equivalent proportion. Now we're going to use some of these properties. It says complete each statement. In number 1, it says if A is to 3 is equal to 7 is to 4, then I know 4A, which is our outside, our extremes, 4 times A is equal to 3 times 7, which gives us 21. In number 2, we have the proportion if A over 4 is equal to B over 7, then we know A over B, which is our numerators, is going to be equal to 4 over 7, which is our denominators. Now we're going to use our means extremes property, or cross multiplying, to find the value of x. So in number 1, I'm going to take 2 times the quantity of x plus 5, so 2 times the quantity of x plus 5 is going to be equal to 4 times 1, which is 4. Now distribute that 2, so I get 2x is plus 10 is going to be equal to 4. Now I'll get x by itself, so I have 2x is equal to negative 6, so x is equal to negative 3. Now a good way to do this also is I can double check my work by plugging that back in. So on my numerator I have x plus 5, so that would be negative 3 plus 5, which is 2. So it gives me 2 plus 4 is equal to 1/2. So that's true, so I know I have the right value, and x is equal to negative 3. Let's look at number 2, the same idea. So I'm going to take 3 times the quantity of x plus 3 is equal to 2 times the quantity of 2x minus 1. So I'll distribute and I get 3x plus 9 is equal to 4x minus 2. I'll bring my 3x to the other side, so I have x is equal to 11, which is my final answer right there. Again, I can plug that in to check it. So I have 11 plus 3 is 14 over 2 is equal to 2 times 11 is 22, minus 1 is 21 over 3, and these are equivalent fractions, so I know that x is equal to 11 is correct. In number 3, I'm going to take x times x, which is x squared, is equal to the quantity of x plus 5 times the quantity of x minus 4. Now I know on the right hand side I have two binomials, so I'm going to have to use FOIL, so I'm going to rewrite I have x squared is equal to, and I get x squared, my outside is negative 4x, my inside is positive 5x, and my last is negative 20. Now when I combine my terms, again I have x squared is equal to x squared plus x minus 20. Now, I'm going to try to eliminate what I can. So I have x squared on either side, so that's going to zero out when I subtract. So I'm going to bring that 20 to the other side, so I have x is equal to positive 20. So now again I can check that. In my first fraction I have 20 over 25 is equal to 20 minus 4, which is 16, over 20. They are equivalent fractions, so I know that x is equal to 20 is the correct answer. And number 4, again, I'm going to cross multiply. So I'm going to have 10 times the quantity of x plus 2 is equal to x minus 1 times the quantity of 3x minus 2. So again, I'll distribute. So I have 10x plus 20. Now I'll use FOIL, and then I have 3x squared. And then my outside is negative 2x. My inside is negative 3x. And my last is plus 2. On the left-hand side, I still have 10x plus 20. On the right-hand side, I'm going to combine my like terms. So I have 3x squared minus 5x plus 2. Now, anytime I have the x squared or higher, I'm going to try to bring everything to one side and see if I can factor it. So that's what I'm going to do now. Subtract 10x. Then I'm going to subtract 20. And I'm left with 0 is equal to 3x squared minus 15x minus 18. Now, I can factor out a greatest common factor. So I have 3 times the quantity of x squared minus 5x minus 6. So now I'm going to solve it. So again, I can still factor. So I have x and x. The second sign's a negative, so I know my signs are going to be opposite. And factors of 6 that when I subtract I get to 5, or 6 and 1. 6 is going to be attached to the negative since that's a negative there, so I have 6 and 1. Now if I were to solve this, I know x plus 1 is equal to 0. I know that x minus 6 has to equal 0, since when I multiply these together I get 0. So by the zero product property, that's true. So if x plus 1 is equal to 0, then I know x is equal to negative 1. And if x minus 6 is set equal to 0, then I know x is equal to 6. So they're going to be my two answers to this proportion, negative 1 and positive 6. In our last problem for today, I have to find x and y. So I have two separate proportions. Each of them have the variables x and y. So in the first proportion, I have 2 times the quantity of x minus 3 is equal to 4 times the quantity of y plus 2. So I'm going to distribute that 2, and I get 2x minus 6 is equal to 4y plus 8. I'm going to put this in standard form, so I have 2x minus 4y is equal to 14. And now I'm going to look at my second proportion. So when I distribute my 5 here, I get 5x plus 5y minus 5 is equal to the same thing. I'll multiply 6 by my other numerator there. So I have 6x minus 6y plus 6. So I'll put it in standard form and bring my x and my y to the left-hand side. So that leaves me with negative x plus 11y. And I'll bring my negative 5 to the other side. It equals to positive 11. Now I'm going to bring down my other equation I have. So I have 2x minus 4y is equal to 14. So I have two equations and two variables. So that's a linear system. So I could either use substitution or elimination to solve. I'm going to use elimination. I'm going to multiply the top equation by 2 and rewrite down here. So I have negative 2x plus 22y is equal to 22. I will add it to my other equation. My x's will zero out, which is what I want. I have 18y is equal to 36, so y is equal to 2. To find the value of x, I'm going to substitute it back in. I'll use the first equation. So I have negative x plus 11 times 2 gives me 22 is equal to 11. Bring that 22 to the other side, and negative x is equal to negative 11, so x is equal to positive 11. So here's my solution using proportions and a linear system.